This is Math Studies section 5.5. In this lesson we're going to be transforming the functions that we've looked at already. So there are different styles of transformations. Translation is when you slide an object. Reflection is when you flip an object. Dilation is when you stretch an object. And specifically for functions, there are different things you can do to the equations of the graphs that will make them do each of these things. So, for any function, if you want to slide it left or right, you can subtract or add a value to x inside parentheses. If you want to slide up and down, you can add or subtract a value outside the parentheses. And so subtracting makes your graph go to the right, and adding makes your graph go to the left. Now that's backwards from what you would think, because you would think that going to the right is the positive direction, so we should use a plus. But because x is the independent variable in those parentheses, it actually acts the opposite way. But k is what you would think it is. Adding something makes the graph move up, subtracting something makes the graph move down. So for example, I'm going to use a quadratic. So how about x plus 2 squared minus 3 is going to make the graph move to the left 2 and down 3. Our standard x squared is through the origin, the U shape through the origin, but instead it's going to be 2 units left, 3 units down, and then it's going to have that same U shape. A reflection or a flip, the basic way to reflect a function, specifically vertically, is to put a negative in front of the equation. There's other things you can do to make graphs reflect horizontally and to make them rotate, but I'll only put the negative in front for now. And so if you do that, I'm going to stick with the same thing. If I have a negative x squared, rather than being the U shape, it's going to be an upside down U because it got flipped down. The last one is a dilation, which is a stretch. If you want to stretch a graph, you can multiply it by any value. It's supposed to be the letter a times the function. So for example, y equals 4x squared stretches the graph vertically, so rather than being, a kind of nice wide U shape, it's going to be a really skinny U shape because the graph got stretched taller and skinnier at the same time. So multiplying by anything larger than 1 will do that. Multiplying by a decimal, which is the same as dividing, will actually stretch it wider. So if I had a 0.5x squared, it would get wider. 0.2 even wider. So we can adjust any of our functions using these different methods to make them transform. Looking at this first one, I know it's going to be a line because it has nothing special fancy about the notation. There's no power 2, which makes a U shape. There's no lines, which make the V shape. There's no square root. It's just the x. The negative 2 will stretch it vertically down, and the plus 4 will make it go up 4. So with all of that in mind, just looking at that, I know my graph's going to be something. I'm trying to make it intersect. I can't draw on this screen. The axis, and it's going to go through positive 4 down with a slope of negative 2. And I have my calculator open so we can check. Okay, I'm lying. My calculator is kind of glitching out, so we'll just take my word on it. That's what the graph looks like. If you have a graphing calculator, you can try typing it in and seeing for yourself. Letter B, I know that it's going to be a U shape because it has the power 2. This plus 2 inside the parentheses will move that U 2 units to the left. And this minus 3 units down. Wow, that's exactly the same one I drew up top, isn't it? Ha ha ha. So 2 units to the left, 3 units down, U shape. Make it look a little prettier than that. The bars will make this one look like a V shape. The -1 means it'll be 1 unit to the right, and the -4 means 4 units down. So V shape right there. Last one, the negative is a reflection. The x plus 5 is a translation 5 units to the left. The +1 is 1 unit up. So that's 1, 2, 3, 4, 5 to the left, 1 up, and it got flipped. Rather than going the positive direction, now it's going the negative direction. Okay, so if you need or want to borrow a graphing calculator, you know where to find me. If you have one of your own, go ahead and use it. It's not necessary for the assignment, but it really does make it easier. When you get down to the exercises, this is just saying, what does a +3 at the back of an equation do? What does a 2 in front of an equation make it do? And so on. So I think this should be manageable, but you can always ask me if you have any questions. Good luck.